This video is going to serve as an introduction to acid-base reactions, so we're only going to cover the basics. We will get more in-depth into acid-base chemistry several videos down. So acid-base reactions in general are a subset of double replacement reactions. An acid and base, when they react together, produce a salt and other products, frequently water. Now, acid-base reactions occur in aqueous solution, and because they're in an aqueous solution, water is not involved in the reaction, except when it is. We'll talk about that in just a little bit. So let's start with some definitions. There are several definitions for acids and bases. We will deal with the Bronsted-Lowry, which are named after two chemists who both came up with this idea of what an acid is. An acid is a proton donor, and a proton is nothing more than a hydrogen cation, H1+. A base is a proton acceptor. Now, logically, you can't donate something if there isn't something to accept it. So by the Bronsted-Lowry definitions, you cannot have an acid without a base. Both must be present. We'll talk about ionizable hydrogens. That is a hydrogen which acts like a cation. Not all hydrogens in a compound are ionizable. When written out, they will almost always be at the beginning of the chemical. For example, hydrochloric acid, nitric acid, sulfuric acid. Now, the carboxylic acids, which is a class of acids, are sometimes written differently, and they will end with COOH. This is ethanoic acid, more commonly known as acetic acid, the chemical which gives vinegar its distinctive odor and taste. This is butanoic acid. In both cases, the hydrogen at the end of the molecule is ionizable, but the remainder are not. If you have one ionizable hydrogen, then that acid is called monoprotic, one ionizable hydrogen. Examples are hydrochloric acid, perchloric acid, acetic acid. If you have two ionizable hydrogens, you have a diprotic acid. Sulfuric acid and oxalic acid are both examples of that. Three ionizable hydrogens is triprotic. The classic is phosphoric acid. And if you have more than one ionizable hydrogen, you're lumped into a group called the polyprotic acids. But even the polyprotic acids will donate one hydrogen at a time. For example, sulfuric acid donates one hydrogen to become the H+ ion and the hydrogen sulfate ion. Once all of the sulfuric acid has been used up, then the hydrogen sulfate ion donates a hydrogen and becomes the H1+ and the sulfate ion. Now, by the Bronsted-Lowry definitions, if you have an acid, you have to have a base. If you have a base, you need to have an acid. Earlier I wrote aqueous hydrochloric acid becomes hydrogen ion, which is aqueous, and chloride ion, which is aqueous. And so you could say, okay, I see the acid, but where's the base? You said you need to have both. Well, let's take a look. This is an aqueous solution, so water is not involved, but it is. A more correct way to write this is aqueous hydrochloric acid interacts with the water molecules to produce a H3O 1+ or hydronium ion, which is aqueous, and the chloride ion. People like me, otherwise known as dinosaurs, frequently will write the ionization in the first way. The more realistic way is the second method, because that shows both the acid and the base. And it's important to remember you need to know both, and that H1+ is the same thing as the hydronium ion. Once again, acid is a proton donor, base is a proton acceptor. So looking at our current equation, we can see that the HCl is the acid and the water is the base. But I could write the reaction the other way. Now the hydronium ion can give up a proton, so it's an acid, and the chloride can accept a hydrogen, so it's the base. Written in the original way, on the product side, the chemical which could be an acid is called the conjugate acid, and the chemical which could be a base is called the conjugate base. Conjugate is used on the product side. The acid, once it donates a proton, becomes the conjugate base. The base, once it accepts the hydrogen, becomes the conjugate acid. So we call the acid conjugate base combo a conjugate pair, or the base conjugate acid is also a conjugate pair. So we take a look at nitric acid plus ammonia becomes ammonium and nitrate ion. You may be asked to identify the acid, the base, the conjugate acid, and the conjugate base, and explain why. Well, the acid is the HNO3 because it has a ionizable hydrogen it can give up. The ammonia is the base because it accepts the proton. That makes the ammonium the conjugate acid because it can now donate a proton. And the nitrate ion is the conjugate base because it can now accept a proton. So the HNO3 and the NO3 1- is a conjugate pair. The ammonia and the ammonium is a conjugate pair. Here's one for you to try. Identify the acid, the base, the conjugate acid, the conjugate base, and explain why. Go. The pH4 is the acid because it donates the proton. That makes water the base. So the pH3 becomes the conjugate base because it can accept a proton. The other three hydrogens are not ionizable. And the hydronium is the conjugate acid because it has a proton to donate. So let's take a look at this and do the same thing. Give me the acid, the base, the conjugate acid, and the conjugate base, and explain why. Go. Here, the water is the acid because it donates a proton to the ammonia. The ammonia is the base as it accepts the proton from the water. That makes the ammonium the conjugate acid and the OH as the conjugate base. So let's take a look at the last two equations. In the first, the water accepted the proton. It was a base. In the second, the water donated a proton. It's the acid. Depending upon the situation, water can be either an acid or a base. Last definition. Any compound which can be either an acid or a base is called an amphoteric substance. So to review what is basically a lesson on definitions, an acid is a proton donor, a base is a proton acceptor. An ionizable hydrogen is a hydrogen which acts like a cation, but not all hydrogens in a compound are ionizable. Usually, the ionizable hydrogens are written as the first element in the compound. Sometimes, not always, for carboxylic acids, which ends in COOH, the ionizable hydrogen is written at the end. When an acid loses an ionizable hydrogen, it becomes the conjugate base. When a base accepts a hydrogen, it becomes the conjugate acid. The acid and the conjugate base, or the base and the conjugate acid, are called conjugate pairs. And a compound which can act as either an acid or a base is an amphoteric compound. And don't forget, H1+, which dinosaurs like me frequently use, is the same as the hydronium ion. They are absolutely synonymous. And that's the intro to acid-base. We'll actually come back to this down the road when we go into more detail in acids and bases.